Hi guys, welcome to Abby B Vlog. Today's episode in Mathematics in the Modern World is about set. To start with, let's define set. Set is defined as the collection of things, usually numbers. It is also represented in a closed or number or a letter inside the brace is what we call element. So one of it is called element. And the symbol for element is epsilon. Okay? So number 1 is element. Number 3 is element. Number 5 is also an element. All of these are elements. So let us now identify or be recognized with the different writing or steps on writing a set. There are two methods of it. We have Brewster and rule method. In Brewster method, we just simply have the list. So we just write every details of it. While in rule method, we write it through sentence. So we write it to sentence. So let's have an example for Brewster method. We have here a rule method sets. And we're going to convert this rule method set to Brewster set. Okay? A is equal to X such that this dot is called such that. Okay? We read it as such that. X such that X is the letter in algebra. We have 2A here. So therefore, we're going to eliminate 1. So we're going to eliminate this in writing the set. Okay? Therefore, we write a set A, and then we copy the letter, no? So A, L, G, E, B, R. So we have this. Okay? A, L, G, E, B, R. So this is now the Brewster. Okay? This is now our Brewster method. Okay? So this is the Brewster. Therefore, if this is the Brewster, what is this? This is the rule method. Okay? Now let's have the second one. B is the set with even numbers less than 6. So therefore, we have B set, and then less than 6, that's 2, 4. Okay? Guys, be sure that you are familiar with odd and even. We say odd, it is 1, 3, 5, 7, 9, 11, 15, 17, and so on and so forth. We say even, it is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on and so forth. So you have to be familiar with that. And don't forget the word that we usually say if there's our enemy. We say usually, we're even. We say we're even, it is because the other man kick you. For example, he kick you, and then you kick him, you're even. You are 2 now. Okay, that's why 2, even. Okay? If 1, you just kick him, you're not even. So it's odd. Okay? We're not saying we're odd, but we're saying we're even. Okay? So don't forget that one. If you don't remember odd or even, you say even, we have 2. 2 person. He kick you and you kick him. That's 2. That's why we're even. Okay? Now, we have even. And it is less than 6. 2, 4, 6. Less than 6. That is 2 and 4. That's why we have 2 and 4 here. Okay? Now, for the problem number 3, x such that x negative 5 is equal to 8. So to make it 8, what is the value that we need? So we have C is the set of, so this is negative, so 5, it could be 13. Okay? So do you know why? So we have 13 minus 5, it's 8. So that's why we write 13 here. So C is equal to set 13. This also set. Actually, we call this set as singleton. Okay? We are going to discuss it later. Now, for number 4, D is equal to X such that X is the vowel letter of the alphabet. What are the vowels? The vowels letter. That is what? So we have A, E, I, O, U. And how about the consonants? The consonants are B, C, D, F, G, etc. etc. And so on and so forth. Okay? So these are the rooster. Okay, the rooster method. Now, if this is the rooster, these are the rule method. So these are the rooster method. These are the rule method. These are the rule method. This, okay, so before we go on to the different types of sets, I want you to remember all of these because these are the basic thing that you have to need in identifying or solving some problem sets in set. First, we have the whole number. Say whole number, it starts from 0. You just count it. 0, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. We start from 0. Natural number, you start from 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So on and so forth. Then integers. Say integers, there is a 0 in between the two numbers with negative sign also. So we start, or I just present it here, negative 3, negative 2, negative 1, 0, 1, 2, 3. All of these are integers with negative sign. Okay? If it is in straight line, it is automatically integers. And don't forget, if there is a negative sign, then positive sign, it is an integer. Now, let's go with the rational number. Say rational number, it can be divided into 2. Okay? So we have 1.5 or 3.2. Okay? So we divide it. So if we divide this, we have 1.5. And that is rational number. There's an exact point. 1.5. Not 1.5111111. It's not a rational number. If there is a repetition or a continuous number after the decimal point, it is not a rational number. We call it as irrational number. A great example of it is pi, which has the value of 3.5, 3.14, 15, 16, and so on and so forth. Or the square root of 2. These are the common irrational numbers. Then algebraic numbers. Say algebraic numbers, it is represented in 3 terms or 2 terms. So we have 2x cubed minus 5x plus 39 equal to 0. So it is represented in 1, 2, 3 terms. But you can also have 2 terms. The 2 terms can be a representation of algebraic number. So now let's go to set or type of sets. To start with, let's have the empty set. You say empty set, there is nothing. No element. An example, a set such that x or x such that x is a natural number. X is less than 1. And less than 1 could be 0 or -1, -2. And those are not natural number. The natural number is 1, 2, 3, 4, and so on and so forth. That's why it is empty set. The second one is the finite set. Finite set is countable numbers, meaning there is an endpoint. Example, a set is equal to 2, 4, 6. There's nothing at all. Only 2, 4, 6. And we know that these are even numbers. Set B have 1, 3, 5. Okay? So let's have the number 3 set. Infinite set. Say infinite set, indeterminate. Meaning, we cannot identify what is the number or what is the ending point. Just like with an example, a set with an element or with a set of x such that x is an even number. What is the even number? We don't know. We know that there is an even number, but we don't know the endpoint. We can start from 2, but where can we end up the even number? That's why it is indeterminate. Infinite set. Infinite. There's a never-ending story. Okay? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, until the end of time. Okay? 1, 3, 5, 7, 9, 11, and so on and so forth, and so on and so forth. Because it is not determined. There is no endpoint in infinite set. That's why it is called infinite. So let's have the subset. In subset, there is a large set and least set of elements. So here, in our problem set or in our sample, A is a set of x such that x is an even number. B set have 2, 4, 6. In this set, the set A is infinite, while here, it's finite. Therefore, the 2, 4, 6 can be within the A. So if this is our A, 2, or this is our B, 2, 4, 6. These are set B. And then, set A can be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on and so forth. 3 dots. 1, 2, 3. Meaning there is a never ending because it is infinite. So therefore, we name it as B is a subset of A because the B submerged to set A. This is our set A. So it is the B is within the set A. That's why B is a subset of A. Is a subset of A. Number 5, disjoint set. 2 or more sets with no common element. Say no common element, there is no commonality between set A and set B, or first set and second set. There is no common element. Example, we have A set vowels, B set consonants. So they don't have the same element on this set. Okay? Now, let's have the number 6. Joint set. 2 or more sets with at least one common element. Example, A set is 1, 3, 5. And then B set, we have 2, 3, 4. So we have common, number 3. Okay? This is our join set. Okay? There is a join element from set A to set B. Because according to the definition itself, 2 or more sets with at least one common element. Let's have another example, the letter C. C element, for example, we have 3, 4, 3 and 4. So, we still have 3 here. So, the commonality between these sets is number 3. So, therefore, they can be joined set. They can be joined because of one common element. For the 7th type of set, we have the equivalent set. Say equivalent set, 2 or more set with same number of element. Same number of element. Okay? So we have here A set 1, 2, 3, 4. And then B set 5, 6, 7, 8. So all of these are natural number and can be continued. So this is 1, 2, 3, 4, 5, 6, 7, 8. So that is equivalent set. Okay? The next one is the equal set. 2 or more set with the same element. So A set is 1, 3, 5. Then B set is odd. We know that 1, 3, 5 is odd. Therefore, if this is odd and B set is odd, they are equal. So we are done with the different types of sets or the 8 types of sets. Now let's proceed to the basic operation of sets. To start with, let's have the union set. Union sets are 2 or more sets combining of sets. Or there's a combination of these sets. An example of it, we have A, 1, 2, 3, B, 2, 4, 6. When we combine it, we have 1, 2, 3, 4, 5, 6. So we call this one as A union B. The representation of union is just like a U shape. Okay? A union B, meaning there's a combine between set A and set B. Okay? So there's a combination of these two sets. Okay? Next, for the second one, or for the second operation, we have here the intersection. The intersection have 2 or more elements in common. Say common, there is the same number. Okay? The same number, the same letter, the same object, or the same subject. So we have here as a diagram. So these are set A and set B. This shaded part is what we call intersection point. The intersection of A and B. So let's have an example here. A set is an element or is a set of 1, 3, 5. Then B set 2, 3, 4. The intersection is 3 because the common here is 3. That's why A intersection B is 3. Let's have the different set. We have 2 scenarios that is happening in different sets. So by the way, let's define it. The difference of the 2 sets is the elements resulted when the elements common 2 sets are subtracted from the minuend set. We have here A minus B. it is represented this way. So whatever would be the point of intersection is not included on A minus B. Okay? We focus on here. So example. So let's put this in an example. A have 1, 2, 3, 5. B set have 2, 4, 6. Then, the difference of A and B is 1, 3, 5. As you can see, guys, there is a common number that is 2. So that's why 2 is not included in the difference of A and B. Okay? Now, for the second scenario, A and B set. The B set is shaded this time as compared to A minus B. The A is shaded. Here, B is shaded. So therefore, B minus A is 4 and 6. We focus on 2, 4, 6. The common is 2, therefore the 2 is eliminated. We don't copy the 2, only 4 and 6. So the difference of B and A is 4 and 6. So let's have the complement. So U then C, the union of complement or complement of U. So we have this element found in the universal set that is not found in any of the subset of the universal set. Okay? So meaning anything that is not within the union or the subset of the two set, for example, set A and set B. So anything that is not within the two is the complement. Okay? So it is the representation of complement is UC is equal to U minus close and open parentheses U. This is the union. This is the union. Yeah. The union of B. Wait. So we have UC is equal to U. So UC is equal to U universal minus the union of A and B. So it is represented like this. So we have set A and then set B. There is a union between set A and set B. Then, the outside the union of set A and B is the complement. Meaning, the element that's not included between A and B. But of course, all of it is what we call universal. Universal set. Okay? So how are we going to identify or know what is this all about? So I have here an example. A is a set of odd less than 7. So in mathematical terms or another way, we have 1, 3, 5. Okay? Then B is 2, 3, 5. Prime number, the 2 is prime number. 2, 3, 5. So we start from 2. Okay? Then the union or the universal number less than 7. So we're going to combine set A and set B. So we have 1, 2, 3, 5. 1, 2, 3, 5. Okay? Then the complement. So 1, 2, 3. The 4 is not included. So we put 4. And this is 7, therefore there is 6. So we have complement. Complement of the universal is 4 and 6. So that's all for today, guys. Yes. Oh, that's all for today, guys. I hope you learn a lot from the mathematics in the modern world for today. Our today's episode is about hindi. So that's all for today, guys. Nahuli ko na nga, no? So that's all for today, guys. I hope you learn a lot from the discussion today about the types of sets and the operations of set. I hope you like our discussion today. If you like it, please don't forget to subscribe and put the thumbs mark or click the button, the like button, so that you will be notified once there's a new uploaded video in the mathematics in the modern world. Bye-bye! See you on the next episode!